Hello, today we will be discussing the organization, path and function of three ascending sensory tracts, concentrating on their organization within the brainstem. The three tracts that we will be describing are the dorsal column, the spinothalamic tract, and the spinocerebellar tract. We will be looking at 7 cross-sections of the brainstem and spinal cord. These will be the cervical spinal cord, caudal and rostral ends of the closed medulla, open medulla, pons, and caudal and rostral ends of the midbrain. The dorsal column is involved with the reception of stimuli related to vibration, deep touch, proprioception, and two-point discrimination. The dorsal column can be divided into 2 tracts, the gracile and cuneate tracts. The gracile tract is present throughout the entire length of the spinal cord. It carries sensory information from the lower limbs and the inferior trunk. The cuneate tract is present only from approximately T6 upwards. It carries finer sensory information from arms, neck, and superior trunk. The gracile tract lies within the medial region of the dorsal funiculus. The cuneate tract pushes it to a more medial position as it appears. In the rostral closed medulla, synapsing to secondary neurons occur within the gracile nucleus and cuneate nucleus, which are positioned similarly to the respective tracts. Decussation follows as the tract moves towards the ventral surface, forming the medial lemniscus. The tracts maintain their relatively medial position in the pons. It lies medially adjacent to the spinothalamic tract. Projection into the midbrain positions the medial lemniscus lateral to the red nucleus and ventral to the spinothalamic tract. Projection to higher cortical areas occur via tertiary neurons in the thalamus. The spinothalamic tract relays sensory information of rough touch, pain, and temperature. The primary neuron enters via the dorsal horn. At approximately the same level, secondary neuron synapsing and decussation occurs. In the spinal cord, the tract is positioned in the ventral funiculus, dorsal to the ventral medullary reticular spinal tract. The tract ascends to the rostral ventromedial region of the medulla. It moves dorsally as it reaches the pons, where it lies dorsal to the corticospinal tract and laterodorsal to the medial lemniscus. The tract moves further dorsally in the midbrain, positioned lateral to the reticular formation, whilst maintaining its dorsal position to the medial lemniscus. Projection towards the thalamus then leads to synapsing to tertiary neurons and higher cortical areas. The spinocerebellar tract projects unconscious proprioceptive information to the cerebellum via the spinal cord. There are 2 pathways within the spinocerebellar tract, the ventral spinocerebellar tract and the dorsal spinocerebellar tract. Primary neurons of the ventral tract conduct proprioceptive information from inferior regions of the trunk and lower limbs. For the ventral tract, synapsing to secondary neurons and decussation occurs around the level of entry to the spinal cord. The tract ascends contralaterally along the surface of the lateral funiculus. It maintains the positions in the medulla, positioned laterally adjacent to the pyramids. It then shifts medially in the pons, continuing to ascend and joining the superior cerebellar peduncle in the midbrain. The ventral tract then decussates as part of the superior cerebellar peduncle, descending back to the pons where it exits to the cerebellum. The dorsal tracts conduct proprioceptive information from the lower limbs, trunk, and upper limbs. The tracts synapse approximately at the level of entry to the spinal cord and ascends ipsilaterally along the surface bordering the dorsal and lateral funiculi. It then shifts ventrally to occupy a position along the lateral surface of the closed medulla before projecting to the cerebellum via the inferior cerebellar peduncle in the open medulla. The spinocerebellar tracts do not have associated tertiary neurons. This is because they do not project to the thalamus or higher cortical areas. We hope this was a helpful learning tool.